Let's take a look at this practice. Example number 1. What do you guys believe is a wisest choice? To cancel out x's, 2, 3, 4, y's, 1, 4, 6, z's, 1, 5, 10. Z's? Okay. Probably wouldn't have gone with z's, but it's okay. Let's go with z's. All right. So if we want to cancel out z's, which two equations are we going to use? First and second? All right. So let's go with the first. And what are we going to do to the first? By regular 5. That way the negative 5's, oh no wait, negative 5, right? Yeah. Whoops. That way the positive 5z will cancel out with the negative 5z. All right, so let's multiply everything by negative 5. So we're going to end up with a new equation that reads negative 10x minus 5y plus 5z equals negative 25. And the middle equation, we're just going to leave it the same. And why did we modify the first one? To get the z's to cancel. And that's exactly what's going to happen. The z's cancel. And what kind of equation are we going to have? We're going to have a negative 7x. We're going to have a negative 1y equaling negative 25. Ladies and gentlemen, that is step 1, right? Okay, so on that first flap of your flip chart, that's what you need to show. And you might as well box this in and call it new equation number 1. Right there. That's new equation number 1. Okay, now it's time for step 2. So on the second flap of your flip chart, you're supposed to think, go back to the original, use the equation you have not used. So I've used the top one, I've used the middle one, so I need to use this bottom one. And you know what? If we want, we could make this bottom one look nicer. Huh? Yeah, it's 4, 6, 10, 14. We could divide this whole thing by 2 to make it look nicer. Now, you don't have to, but why not, right? You could do whatever you want to an equation as long as you do it to the whole thing. So if we take the one we have not used, divide everything by 2, it'll make it nicer. So this is what I'm going to do. I'm going to circle this, draw an arrow. I want to put divided by 2 in a cloud. Then I want to show that one that I have not used divided by 2. It's going to be a negative 2x. It's going to be a minus 3y. It's going to be a plus 5z. And it's going to be a equals 7. So we need to use the one we have not used and any other one to get the same variable to cancel. So if we canceled the z's on the first step, I need this z to disappear. So which one am I going to use? The middle one. The middle one's ready to go, especially because we modified this bottom one. So let's rewrite that middle one without doing anything to it. We're going to rewrite it down here. So we're going to have 3x plus 4y minus 5z equals 0. And we are going to combine the lines. We get a 1x, we get a 1y, we get no z's, they cancel out, and we get 7. And ladies and gentlemen, we have done step number 2. What are we going to call this? Yep, new equation number 2. Okay, so if you're working on your flip chart, the third flap should read to create your new 2x2 system. Create your new 2x2 system. That's your third step. So you're going to take the new equation 1 and your new equation 2, and you're going to put them together. New equation 1, new equation 2, we're going to put them together. So here we go. 7x minus 1y equals negative 25. And then the other one is 1x plus 1y equals 7. Wow, this is working out pretty nice because, oh, forgot the negative on the 7? Yeah, you're right. Sorry. Thank you. Wow, so I mean, that's a good example right there. If you're not very careful and you forget one negative sign, you could keep going and you're going to do a bunch of work and it's not going to work out. Yeah, so you got to be very, very, very careful. Thank you for catching my mistake right there. Anyhow, this is our new 2x2 system. So do I need to modify anything? No, the y's are ready to cancel. So let's just combine them. The y's eliminate. I'll have a negative 6x equals negative
18.
And my final step will be to divide by negative 6. Divide by negative 6. X will equal positive 3, ladies and gentlemen. So that's one answer of my 2x2 system. So what am I going to do? I'm going to plug it back in to any one of my 2x2 system equations. So do we want to go with the top one or the bottom one? Bottom's definitely easier because it's just x plus y equals 7. So let me get that bottom one and let me rewrite it. Instead of x plus y, I want to put parentheses plus y equals 7. Again, you don't need the 1x. You could just put x plus y equals 7. There it is, x, the parentheses, plus y equals 7. Take that 3, that's x, and plug it right in there. So you have an equation that reads 3 plus y equals 7. Let me rewrite it. 3 plus y equals 7. Get that 3 over to the other side by subtracting 3. We have y equals 4. Ta-da! So we have two answers so far. We have x equals 3, y equals 4. And this is the fourth step. It's all about substitution, right? So let's go back to the original and pick any one you want, either the top, the middle, or the bottom. Which one do you guys say? Top one looks all right. So let me rewrite the top equation, but instead of x and y's, I'm going to put parentheses. So let me rewrite that. Here we go. 2x, 2 parentheses, plus y, plus parentheses, minus z equals 5. All I did was rewrite this top equation, but instead of x's and y's, I put parentheses because I want to put my x and my y value right in those parentheses. So put the 3 right in there for x, put the 4 right in there for y, and then do the math. 2 times 3 is 6. 6 plus 4 is 10. So we really have 10 minus z equals 5. This is getting ugly. How about this? Let me rewrite this over here on the side. 10 minus z equals 5. So my next step would be to get rid of the 10 by subtracting 10. Subtracting 10 cancels out. Negative z equals negative 5. Final step is to just change the sign. Z equals 5. Ta-da! So our ordered triple is, the answer is 3, 4, 5. Okay, so that was our first problem. Now, in any type of system, if you're working on something and you're trying to cancel, like let's say right here, when we had our 2x2 system, if we were trying to cancel out y's, and if the x's and the y's canceled, then you ended up with something like 0 equals negative 18, what would you say? No solution. Now, if everything cancels, the x's, the y's, and these, and you end up with 0 equals 0, what do you say? Infinitely many solutions. And that does happen as well right here on 3x3 systems. It's not just on 2x2s, right? So if that ever happens, those special cases, just remember, if it's true, you say infinitely many solutions. You could say IMS. If it's impossible, like 0 equals 5, that doesn't work, you say no solution. Okay, let's jump to number 2. And step 1 is to pick 2 equations and get a variable to eliminate. Whenever I do this, again, I think 2, 6, 3. I look at the numbers, the coefficients in front of x. I look at the coefficients in front of y, 1, 3, 2. I look at the coefficients in front of z, 1, 4, 3. So what do you think is the best to go with, canceling out x's, y's, or z's? And it doesn't really matter. I mean, you could choose to cancel out x's. I could choose to cancel out z's. There's many roads to the same place. But I don't know. Let's pick one. What do you guys want to cancel? X's, y's, or z's? Okay. I would go with y's, but if you guys want x's, let's go with x's. What do you guys say? X's? X's. Why not? Let's go with x's. So if I wanted to cancel out x's, which 2 equations would I use?
First one and the last one.
First one, and I would go with the first one and the second one if I want to cancel out x's, right? So for the first one and the second one, I'm going to have to multiply that first one by negative 3. That way I could get a negative 6 that will cancel out with the positive 6 that's down here. So let's multiply the top equation by -3, giving us a new equation over here that reads -6x plus 3y minus 3z and equaling +6. So that's our new modified top equation. And we modified that top equation to be able to combine it with the middle one so that the x's will cancel. So let me rewrite the middle one right here. So I just rewrote it right there, right below the modified one. And now let's combine the lines and get those x's to eliminate. That's what we wanted in the first place. So I now have 6y minus 7z equaling 14. And ladies and gentlemen, this is step 1. This is the equation that we're going to call new equation number 1. New equation number 1 right there. Any questions? Okay, so let's move on to step 2. So we want to use the one we have not used yet. Which equation have I not used yet? This one, this one. The third one, that's right. So we're going to use this one, and I want to combine it with any other one, but I need the same variable to cancel. Let me emphasize that. I need the same variable to cancel. So if I canceled out x's, I need the x to disappear on this with this third one. If I canceled out y's, I would need the y to disappear. If you don't get that same variable to cancel, the new 2x2 system that you create is not going to be worth anything because you're going to have different letters that you're not going to be able to solve. So anyways, let's combine the third one that we have not used with the second one, and let's get those x's to cancel. So let's take this third one that we haven't used, and let's multiply it by what? 2. Let's multiply it by times 2, and I want to draw an arrow down here. I want to rewrite it down here, multiplying it by 2. That's going to give me a -6x, a +4y, a +6z, and equals -12. Are you with me? And of course, we're going to just rewrite this middle equation. I'm going to rewrite it down here right below it. Let me do that. 6x plus 3y minus 4z equals 8. Once again, I took this one that I have not used. That was step 2. Use the one you have not used. And what did I do? I decided to modify it by 2 to get the x's to cancel. The same variable that canceled over here, I need that variable to cancel also. So I modified it by 2. This middle one, I just rewrote it. Let's combine the lines. Let's eliminate those x's, that same variable that got eliminated on new equation number 1. So I have 7y plus 2z equals -4. This is new equation number 2, NE number 2. Okay, so now we're on our third step. Okay, so if you're using your flip chart, that third step should say create a new 2x2 system, right? So we're going to take new equation 1, new equation 2, put them together, creating a new 2x2 system. So my new 2x2 system will be 6y minus 7z equals 14, and it's going to be with 7y plus 2z equals -4. So this is our new 2x2 system, and we all should be able to solve a 2x2 system with elimination method. So what would you like to cancel, y's or z's? Z's look a little bit easier, right? Because if I wanted to cancel out y's, I'd have to change this to a 42 and a -42. It's easier to have a -14 and a +14. So let's modify that top equation on the 2x2, on the new 2x2, by multiplying it by 2. Let's modify the bottom one by multiplying it by 7. And let's get our new modified equations up here. 12y minus 14z equals 28. And the bottom one, 49y plus 14z equals -28. So when we combine the lines, yeah, the z's, we wanted them to cancel. 12 plus 49 is 50, 61, right? 61y. And it equals 28. Take away 28 is 0. That's actually a good thing, because to get rid of the 61 in front of the y that's being, are you kidding me? Okay, sorry about that. So let's divide by 61, divide by 61, and 0 divided by any number is still 0. So the y answer is 0. And that's not impossible. That's a number, right? Y equals 0. So that's an actual part of the answer. So let's get the other answer by plugging it back into our 2x2. So this is technically step 4, where it says to solve it by elimination method and substituting, and you just keep substituting until you get all 3 answers. So if you get that 0 and plug it into, what do you guys want to do, the top or the bottom? Top. Okay, so on top it says 6y, but instead of y, I want to put times the 0, minus 7z equals 14. So 6 times 0 is 0. You could just make it disappear. And then finally just divide by -7, divide by -7, and z will equal -2. So that's our answer to our 2 by 2, but we want our complete answer to our 3 by 3, which means we take that z and y value, plug it back into any original equation that has x's and y's and z's, and find that missing value x. So which one should we go with? The top, the middle, or the bottom? Top. Okay, so the top one, let me get more. Again? Is this really happening? This happening? Okay, hold on. So up on top, we have 2x minus y, I'm going to plug in y, plus z, I'm going to plug in z, equals -2. So we're going to plug in the z value of -2 right here. Let's put -2 right in there. Let's plug in the y value of 0 right in there. And it's just some simple math that we have to do. We have 2x. What's -0 plus -2? That's just -2, right? It's like if the minus 0, you can just scratch that out. It's not even there. So you really have 2x minus 2 equals -2. Then you continue to solve plus 2 plus 2. You have 2x equaling 0. Really? Okay. So divide by 2, x equals 0. So our answer for this one is the ordered triple, 0, 0, -2. So on that last tab of your flip chart, I think it said special cases, right? You don't have to copy this one down. I think this one's a special case, so let's see how this works out, all right? Number 3, would you like to cancel out x's, y's, or z's? Y's is a good choice because 1, 2, and 1, that seems pretty easy to deal with. I would rather deal with 1, 2, and 1 than 2, 4, and 3, or 3, 2, and 6. So let's go with y's. And how are we going to cancel out y's? Which one do we want to use? Which one do we want to modify? The first and third. We could go first and second. It doesn't matter. But we're going to go with the, I guess, first and third you guys decided on. So first and third, the top one, we're going to change it by multiplying it by -1. And we're going to get -3x plus y minus 2z equals -4. And the bottom one, we're going to leave it exactly the same. I'm just going to rewrite it right there. So now I'm going to combine the lines and eliminate the y's. Since we decided to eliminate y's, that's why we modified the top one. The y's are gone. Let's get our new equation. That's a -1x. That's a positive 1z. And that is a 6. Okay, so this is what we call new equation number 1. New equation number 1. It's right there. Step 2 is to go back and use the one we have not used. Which one have we not used? The middle one. So let me rewrite the middle one right here because I need to use it. So there's my middle equation. Now I want the same variable to cancel. And this is very, very important. If you don't get that same variable y to cancel, I need this -2y to disappear. So what am I going to do? Which one am I going to modify? Either the first one or the third one. It doesn't really matter, right? I want to go with the third one. I want to modify this third one by multiplying it by what? By -2. Okay. So when I multiply it by -2, I want to draw an arrow and actually write it right here. -2 times 2, that's -4x. And then -2 times -y, that's positive 2y. And then -2 times positive 3 is -6 with a z. And then equals -2 times 10 is -20. Everybody with me? So again, step 2 was go back and use the one you have not used. I wrote it right here. And of course use any of the other ones to get the same variable to cancel. So I modified the bottom one, that way the same variable y will cancel. So my new equation number 2 will be 2x minus 2z equals negative 28. Yay? So this is new equation number 2. Okay. Now step 3 is to create your new 2x2 system with those two new equations from step 1 and step 2. So let's create a new 2x2 system. It's going to read negative x plus z equals 6. That's new equation number 1. And then new equation number 2 right below it, 2x minus 2z equals negative 28. And when we start modifying this new system to get something to cancel, which one would you guys like to cancel, x's or z's? X's. Okay, so I'd have to multiply the top by what? By 2. So my new equation up on top will be negative 2x plus 2z equals 12. And my bottom one, I'm just going to rewrite it. And of course, we modified the top one so we could get those x's to cancel, and they did cancel, but the z's also cancel, giving us nothing on the left side of the equal sign equaling something on the right, which would be a negative 16. So what do we say when we see 0 equals negative 16? You say no, as in no solution. Or you could just put the no solution symbol. Okay, so this is a special case that you could have put on the final tab of your flip chart. Of course, there's some that are no solution. There's also some that are infinitely many solutions. If you end up canceling things out and you get 0 equals 0, then you would say infinitely many solutions, IMS. So step 1, right here on number 4, step 1 is to pick two equations and get something to cancel. So what would you like to cancel? X's, Y's, or Z's? X's look good, okay. So which two are we going to pick, and are we going to modify anything? Nope, just the first and the second one, right? Okay, cool. So let me just rewrite the first one right here and rewrite the second one right there, and we could combine them and cancel X's. Let me rewrite them. There they are. Okay, so we don't need to modify anything. We just combine them, and those X's that we wanted to cancel out, they eliminate. So we have a new equation that reads positive 3y minus 1z equals 5. And this is step 1. This is new equation number 1. NE for new equation number 1. It's right there. Okay. And this was step 1. Okay, step 2 is to go back and use the one you have not used yet. That would be the third one, right? So you could technically leave it there and get modify one and write it right below, but I like to separate my work, so I'm going to rewrite it down here. There it is. All I did was rewrite it. And then I need to pick any other one, but I need specifically the same variable to cancel. So I canceled out x's up here. I need this negative 2x to disappear. So which one do I want to use? The top one or the middle one? The first one, the top one, okay. If you want to save some time, you could do this. I'm going to circle it, and I'm going to draw an arrow, and as I'm drawing an arrow down, I'm going to put multiply times 2 in a little cloud. That way, when I write it down here, I'll already have modified it by multiplying by 2. So I'll have 2x, I'll have 10y, I'll have negative 4z, and I'll have negative 2. So to save myself a little bit of time, I already modified it as I brought it down. And again, the whole purpose of modifying it is to get that same x value to cancel. So I'm going to have a new equation that reads 3y minus 1z equals 5. And ladies and gentlemen, this is my new equation number 2. New equation number 2. And this is step 2, technically. Step 2. So step 1 was up here, and we produced new equation 1. Step 2 is right here. We produced new equation number 2. Step 3 is to create your new 2x2 system. New 2x2. with those new equations, new equation 1 and new equation 2. So when I create this new 2 by 2 system, here's new equation 1, 3y minus 1z equals 5, and the other one is 3y minus 1z equals 5 as well. So what do we know about these equations? They're the exact same equation, right? So what does that mean with regards to answers? Infinitely many solutions, right? I mean, think about the graphing. If you were to graph this one and graph that one, it's going to be a line right on top of the other line. They share an infinite amount of answers. So you could just stop right here. See, technically what you're supposed to try to do is, okay, I want to cancel something out. So you're like, oh, I want to cancel the top one, the z's by multiplying the top by -1. So you get -3y plus 1z equals -5. The bottom one stays the same. 3y minus 1z equals 5. But when you cancel, everything cancels. So you get 0 equals 0, which is always true. This is where you say infinitely many solutions. IMS, infinitely many solutions. So that was a special case right there, number 4, which you could use on your 4th tab of your flip chart. And again, just to reiterate, the other special case would be when you're working on a problem and maybe not everything cancels out and you don't end up with 0 equals 0. Maybe you end up with 0 equals 5. Then you would say no solution.